Surprise, I'm back. Happy New Year, everyone. And we're going to kick off this year with a tutorial about generative modeling. Now, I've been doing lots of generative modeling stuff going back to 2019, I think. That's why the bygen add-on exists. And recently, while I've been on holiday, I've been sharing all kinds of weird experiments and tests on Twitter and Instagram, trying out new ways of combining geometry nodes with the modifier stack to create all kinds of new effects, which you can apply to any object you like. Now, I've been getting lots of requests from people asking for breakdowns for those projects. Now, there's a lot of information to cover, and I'm going to try and go over as much as I can. So maybe grab a drink, grab a notepad, and get ready to learn some new geometry nodes tricks. Okay, so before we jump in, we need to talk about the limitations of the modifier stack. So traditionally, if we were doing a generative modeling with Blender, it usually looks something like this. Say we'd have a cube, we'd give it like a subdivision surface modifier. I've done it to a level of 5. Then maybe now we have some extra geometry. I'm going to add a decimate modifier. And you think, well, why are you adding a decimate after you've just added geometry? Well, it's because we can get kind of random-ish geometry going with it, but that by itself isn't particularly interesting. So maybe you'd add an edge split modifier, turn it down to something like 20 degrees. And what it does is it looks for any edges that fit within that degree threshold, and then it splits it from the geometry. And we can see this if we add a solidify modifier. So then if I reduce this thickness to bring it out, here you go, you can see any edges which fit that threshold have now been split. So then if we modify the decimate value, we can see how we're getting these random cranks going. Now, okay, yeah, this is a semi-random shape, and you could apply this to any mesh that you have to get kind of random grooves going, but how can you make this more interesting? Well, first of all, let me increase the subdiv level, and we can see that there are no creases anymore, and that's because all of the angles have kind of averaged out a bit more, so we need to modify that value again. So if I put the edge split down to 10, then we're going to get the grooves again. So again, quickly, this is just a demonstration for how you would traditionally do generative modeling in Blender before geometry nodes came along. So let's push this a bit more. We'd add a displace modifier and put this after the subdivision. Then we might add a new texture. So this will be a procedural one created inside of Blender. Press this button here to go into the properties, change it to something like clouds. Then we can come back and scale down the strength of this. So this is another way of getting some randomization to the mesh while also giving it a bit of displacement. Okay, so the idea behind modeling like this would be if you had like another basic shape. Let me make another cube here with a subdiv, apply that modifier. I'm just going to quickly go into edit mode, choose a face, press O for proportional editing, and move it along. Back in object mode, have this one selected, select our generative object, Control L and copy modifiers. Okay, I just crashed Blender because I made the sin of leaving the subdivision surface modifier on the stack that we were going to copy over. That's something that's very dangerous. If you're making generative styles with the modifier stack, with geonodes, whatever, keep in mind that if you're applying like a pre-made effect like that to another object, you might not know how dense the geometry is on the object you're applying it to. Therefore, it's very, very dangerous to add a subdivision surface modifier to that. So I've got our cubic sphere here again, but I've removed the subdivision surface modifier. Click on our new object, click on the template, Control L, copy modifiers, and here we go. Now again, I can go into edit mode, start choosing faces, pulling them around, go back into object, and it's now generating a new effect around the base mesh. So if we modify it again, go back into object mode, and here we've got something new. Okay, you might think, oh, okay, that looks kind of cool, but what's the use for that? You know, that kind of seems a bit pointless, a bit weird. Well, it's actually got some really interesting applications. First of all, you don't have to make it look as hard and weird as this. You can do all kinds of weird organic shape generation, say if you were generating rocks. It's also got some really interesting hard surface applications. Let me see if I can take a quick diversion from this tutorial file just to show you something I was working on. All right, here we go. So this is one of the test files from a Twitter post I did over the holidays, where you have a quick sculpt base mesh here, like a very low poly shape. You then apply a hard surface faceting style to it, which is basically what I've just told you about here, but with some extra modifiers. So there's like the triangulate, bevel, and mirroring afterwards. This is also in bygen. Side note as well, this is very messy, but a lot has happened in between this video and the last video I put out. I've done an update for bygen where the modify styles have now all moved to a thumbnail interface. So it's under parametric, and you can see it all here. So hard surface faceting here is something you can just apply to any object you like. So if I click on that, click on our base mesh, click apply to selected, and here you go, you got some weird result. But again, I've made the mistake of leaving on the subdiv surface modifier. That's because I'm currently experimenting with it. So side note away, let's carry on with the demonstration. So if you've taken a base mesh and you've generated some weird faceting around it, what you can do is add a remesh modifier. What this will do is basically, if you've got it set to the voxel mode, it will voxelize where geometry is and connect those pieces together. So you can end up with a more manifold mesh from the strange result that you've created. Now, manifold should be in quotes because it really depends what settings you have, because you can just as easily create some holes in between the meshes. But with this, it means that, say if I modify this displacement value, we can now randomize the shape of this generated mesh. Now this would give us a very interesting starting point for if we were doing some kind of hard surface shape like a helmet or some kind of visor or body piece, or if you wanted to generate mechs and stuff like that. By using the remesh, it gives us a consistent geometry density, which would be very useful for sculpting over the top of. And then again, you could retopologize over the top of that and add whatever details you like. So part of the purpose behind this is to interrupt that self-inspiration workflow. So if you had a cube and you were just working from a cube and modeling away, it'd be very, very difficult to inspire yourself into an interesting direction. It'd take quite a long time of just chipping away at this cube before you came to anything interesting. The point of generative modeling in this way is to take that jump from the high effort beginning to finding a starting point of inspiration. So you don't need to start chipping away at a random cube. You can just make a very quick base shape, generate something interesting and go, okay, I can see a starting point here where I can develop something more interesting. That's the point of generative modeling here. That's how I see generative modeling being used in Blender. But of course, lots of people like to just generate random shapes and use that for their artwork, and that's fine as well. So back to our tutorial file, how do we go from this basic weird cubic sphere, faceted odd crevice thing to something much more advanced like this here. This character with a kind of weird golden ancient semi-randomly displaced body armor type pattern. Well, if we click on him, you can see this is only done with 2 geometry nodes trees, and we're going to go through every step of the way here. This is why the video is probably going to be quite long. But one more thing to talk about before we start is the limitation of the modifier stack, which is that each of these modifiers has to work on the previous result. So in edit mode, we can see the original mesh here, and this mesh gets passed to the displace modifier, and then the result of that gets passed to the decimate, and etc. So it moves down like that. This is fine, but it means that if you want to have multiple layers of effects, you can't really do that unless you make multiple objects and try and combine them together in interesting ways. So a demonstration of that would be this interesting kind of vehicular concept generator that I've been working on. This is going to be part of like the first paid pack for bygen. So you can see that here. I've got it already set up here as a preset. But if you take a look at this, there's some interesting faceting going on underneath, and then there's a different surface coming over the top. This is all done in one modifier stack, which you would not be able to do without geometry nodes. You can see that here on the right, I've got the modifier stack. There's a bunch of things going on, and there's 2 geometry nodes modifiers here. This second one is actually making the outer shell. Now, the reason geometry nodes allows for this is because you can reference objects inside of the nodes anywhere you like, any object, anywhere at any time. And you can see we can do this here with the object info node. So say I could like press E over this and choose our original mesh, and then all of a sudden we're using the mesh input of this object as the outer shell input here. And it's giving us a really weird result because obviously it's not really been set up for that. But that's just to demonstrate that you can take objects from different places at any point in the modifier stack and use it to make something new. So you can add extra layers of effects to an object. All right, so I'm going to take my guy here and clear all of his geometry nodes. I'm just going to do some basic setups here. Let's remove the vertex groups. Okay, so we're starting fresh. So I'm now going to tell you how to make that generative effect in geometry nodes by showing you a variety of techniques, and you can mix and match these in any way you like to make your own effects. So without further delay, here we go. So I have my character model. I'm going to go into the modifiers and add a geometry nodes modifier. I'm going to open it up here on the left so we can see it. Now, if you used geometry nodes before, you already understand this, but it's pretty self-explanatory. Here we have the input and the geometry output. So with the regular modifier stack, we can visualize this as being modifier, 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 producing the output geometry. So the first, the second, and the third modifier all working along one line to produce the output. But in geometry nodes, we don't need to do that because we can take this and go anywhere we like with it. So let me just delete those points again. Okay. So the first thing we're going to do is make a set position node and put this in between here. So this is quite self-explanatory. Again, all it does is set the position of the geometry. So if I scrub the values, we've got X, Y, and Z. It's just going to move our original object. Now that's simple, but quite pointless, quite boring. We could just move the object any way we wanted anyway. So what can we do with this? Now we noticed that the offset value here is what actually moves the geometry, but it's doing it all at once. How can we do it individually? Well, in geometry nodes, there are certain variables we can call upon, which modify different aspects of the data for the object. So the normal we can imagine as being the normal direction. So basically the outwards facing direction for every face that exists. If I plug this in, then it's basically just going to offset the geometry along every single normal direction, which is going to inflate the object. So here we have Big Chungus. Big Chungus is very friendly, but not exactly what we want. We basically just invented the Marshmallow Man. So if that's what you wanted to make, then you can end the video now because that's all you needed to do. But basically what this means is we can now modify the position of every face individually by using this normal value, as opposed to unplugging it and moving every face all at once. So what I'll do now is add a vector math node, because normal, as you can see, is this purple diamond here, and that represents a vector value. So when we're modifying this, we're doing it with vector math. So I'll plug this into the default vector math node here, which is set to add, plug that into the offset. Then if I move this, it's basically going to do the same thing that we were doing before, and that's because we're just adding the vector values to all of the normals. So if we're adding to the X value, we're moving them all along the X direction, and that's not what we want. So we're going to set this to scale. And what this is going to do is scale the vector values all at once. So it means we now have control over how inflated the mesh is. I'm pretty sure I went to school with this guy. Anyway, now that we can inflate the mesh, it gives us a platform for displacing it. What I mean by that is we have this single value here, scale, but if we can provide different values to this one for each face, it means that we can offset their inflation scale in different ways. Now, an obvious way to do that would be to use a generated noise texture, but I'm going to use Voronoi because that one always produces the most interesting results. So if I plug the color in, then okay, it does work, but it's not exactly what we want. It's behaving way too strong, but I can of course change the scale of the texture, and that's going to give us some different results. Change the randomization, but come on, that's a bit too much. What are we going to do now? Well, I'm going to add a math node, and I'm going to put it in between here, and I'm going to set it to multiply. So we're essentially just multiplying it by a lower value. So if I scrub this value down, we can see how the effect is now much more pleasant, not over the top. So I can change the scale of the texture now and see how it actually affects the surface. So if you wanted to get a random noisy effect over the surface, then this is a way to do it. You can use whatever other generated textures you like as well. There's a regular noise one if you liked. So we can plug the color in there instead. And you can see how we can make a noisy, almost rocky displacement that way. So this is how you do a simple displacement in geometry nodes. But I'm going to go back to Voronoi for our demonstration. Now, mapping in geometry nodes is a bit different to shader nodes in the way that you don't have as many options available, at least not yet, because there's no actual mapping node, but you can make your own custom ones if you want. So we're going to do this manually. And the way we're going to do this is by taking the position variable, which is basically just the position data for the object, and then adding a vector math node again, because we're manipulating a vector value. So if we plug that in, and then plug this into the vector input of the Voronoi texture, when we move these X, Y, and Z values, we are changing the mapping of the generated texture. So we can now move it across the object. So these are values that you could animate if you wanted to do a kind of weird morphing effect. That's the other good thing about geometry nodes. Any of these values can be keyframed and animated. So that would be the parametric part of parametric or generative modeling, being the parameters that you can change. Okay, that's fine. Let me reset those to 0. One thing I don't really like though is that I want to have this effect of these tiles coming out of the surface without it inflating all of the mesh, because I don't really like his fake nose here. Okay, so what I'm going to do is add a color ramp in between the texture and the multiply value. And what this will do is let us restrict the values so we can have it only discover the islands that we want to displace from the surface. And you can see here, if we check that nose again, that as I'm moving this color handle, we are reducing that inflation and leaving only islands behind. And then again, I can modify the displacement value here to choose what I want to do with those islands. So you can inset them for cool results like that as well. Say if you were doing like a statue that was chipped away. Notice as I'm doing this tutorial, I'm giving you different artistic ideas that you can take away with you before you actually finish the tutorial. It's not an accident. I've tried to keep that in mind while preparing this. So look, we've only just started. Here's a piece of artwork. So yeah, color ramps give you artistic control over restricting the values, but they're a bit tricky to animate. Some people, when animating values like this, prefer using the map range node, which works in pretty much the same way, but you do need to experiment with it a bit because it's basically the same as moving a black and white handle along the range. And these are easier to animate because the values are exposed right here. But for artistic control, if you're a more visually focused person, then the color ramp is an easier thing to use just to get nice results. But alas, what if you don't want to use a generated texture like this? What if you have your own texture? Because after all, using our own textures would give us so much more creative control over the displacement. Well, there is an image texture node in geometry nodes. So what I've done is I've created a cross texture. It's very simple. It's a black square with white crosses going across it. This is a bit of a callback to the Scattershot video where I was talking about doing procedural texturing effects over shaders. So if I choose this and then replace the Voronoi texture with our cross, then aha, here we go. We can see that we're now displacing a cross pattern across the object. Back in rendered view, we can see this here, and that looks pretty cool. And again, we can take our custom mapping here, plug the vector in, and move that along. So if I go back into solid view, and then I can move these values and we can watch our custom texture being mapped along the object. Okay, that's cool. We got some parametric displacement going on. But to give us that extra control in the modifier stack, one thing I'm going to do is take our group input node. You can actually just duplicate this and make another one to keep the nodes tidy. Then we're going to drag this circle here to make a new input and plug it into the image input of the image texture node. That will let us change the image from the modifier stack over here, so I can change it to my circle texture instead. So this gives us some extra control outside of the node tree. Now, one thing to keep in mind here is that if I think this cross pattern is too big, there's no scale value on the image texture node. So how do we change that? Well, that would be an aspect of mapping again. And because it's vector, we need to do some vector math. And if you remember back, we've already used the scale mode in the vector math node. So that's exactly what we need to do. We make a duplicate of this, plug it in between, change it to scale, and then we can scrub this up to increase the scale. So let me just reset these values a bit. 0, 0, 0. I'm going to slightly reduce the displacement there, but keep it in setting. And then here we go. We've made the pattern much higher frequency and it's displacing all along the object. Fine, so that's another pretty cool result. And if we change it to circle, again, the circles are doing it. Now, if I extrude this instead, you can see that we've got some kind of metallic netting thing going on. It's like, you know how some of those metal grates have that weird mesh effect? That's essentially what we've made here. So that's another artistic effect you can take away with you. I hope you're taking notes. Okay, so I want you to be very, very careful with this next bit, because as you can see, if we zoom in, it's a bit messy in terms of the polys, but we can use a subdivision surface modifier as a node. So if I type in subdivision, here we go, we can choose this. And again, be very careful because your computer might not like this. So if I click it in between the geometry here, it adds a bit more geometry. And I can increase the subdiv level. Let's try number 2. Don't crash. Okay, it didn't crash, but it's a way that you can keep adding more and more geometry. I'm going to remove that now because I don't want it to crash. And we're going to move on. Now, one thing you might notice here is that our mapping is quite basic. Let me hide bygen as well to give us some more screen space. So when we look around the object here, we can notice that the texture is kind of stretching along the edges. It's fine when it's front on, but not around the sides. Now, the thing is, in the shader editor, if I have a quick look over here, if I make an image texture node, you can see that we have projection modes, and here there's a box option. So if you were plugging a texture in with the shader editor, there's already a way to project it from different sides. That is not present in geometry nodes. There's no option for the box here, but you can make your own, like I said. So I've got a triplanar node here. This is where again we need to give thanks to Arundel, who I mentioned in most of my geometry nodes videos. He has an ETK toolkit which has a triplanar node in it. But if you want to take a quick look at the nodes here, you can see the general pattern of how it's done. It's basically just making comparisons between the X, Y, and Z values for the normals and the positions to get it projecting from every major side. Now the node that I've made here for it now already has scale and offset put in, so I just need to plug triplanar into the vector. And now if I move the scale, you can see that it's technically projecting from each side. So if I up the scale a bit more, you can see this here. Instead of stretching along the edge, like we have with this scale, we can see these circles going around. If I plug the triplanar in, we now have it projecting appropriately. Now it's not perfect because it's a bit difficult to get perfect mapping around a complex object because you can see the seam lines here where it's trying to reconnect, but it's good enough. So back in the rendered view here, we can see the effect as it tries to wrap around. Okay, so that's a basic introduction into displacement for geometry nodes. But now we're going to make things a bit more complex. So we're going to leave this geonode tree behind and we're going to make a new geometry nodes tree. And in this one, we're going to talk about the benefit that GeoNodes has over the regular modifier stack, and that's in the way that it can reference the same object multiple times at different points in the stack. So what I'm going to do here is we have our output geometry for the node tree we've just made. So the GeoNodes tree is providing its result all the way down to our new one. But instead of using this, we're going to unplug it because we don't want it. What do you mean we don't want it? We just spent all that time making that result. What are we going to do with it now? Well, we're going to make an object info node, and we're going to press E while hovering over the value, choose our base mesh, and plug this into our output. So now we're taking the original base mesh and using that. But what about our original result? What are you doing? That doesn't make any sense. All right, I'll stop asking the rhetorical questions. I won't, but I'll try to. So we're going to use the join geometry node. What this will do is allow us to combine two sets of geometry. So if I plug that in and plug our created result from our previous node tree in, and then plug that into the geometry, then essentially we're duplicating our base mesh and our original result. Now we don't really want to do this, but I'm just demonstrating to you how you can combine geometry so we can bring in another object from elsewhere in the scene and add that to our original result. Okay, so forget that node for now. We're going to make a change to the original node tree to make this work properly. So we're going to go back to that node tree. We see our geometry input here. We're going to make an object info node. And again, plug this into our base mesh. Now we're going to take the geometry output of this and replace the original input. And then again in our second node tree, let's plug that in. Okay, so that might be a bit confusing. What we're doing here is we're no longer using the base mesh of this object. Now both node trees are pointing towards a separate base object here. So whatever changes we make to this object is going to be represented in our geometry node result here. So if I take this and kind of move his shoulder around, you can see the result changing. This is how you can get complex generative layered effects using the modifier stack in GeoNodes, because both of these trees are now referencing the same base mesh object, but they're doing different things to it and then combining that result. Well, they will be when we're done. Does that make sense? I hope so. If not, it's going to make more sense when we start doing stuff. So we have our base mesh here. We're going to make a distribute points on face node. Plug the geometry in, because what I want to do now is, now that we have our mesh that's been displaced, I want to do something a bit different. I want to create new content around it, like a new mess of geometry, and we're going to do that by using voxels. So instead of taking the original geometry and moving it around, we're going to create new geometry around it. And then when we've done that, we'll combine that with our original effect, and that's going to give us a new generative style. So if I plug just these points into the geometry output now, you can see that we have points being scattered around where the object should be. Let's move that up to something like 700, and we can see the effect represented. If I do bring our join geometry node back and combine these points with our first result, then we can see, it's a bit difficult to see, but underneath this is our original result and the points are layered on top of it. So if I scrub that value down again, you can see that we have the displaced result and points on top. But I'm just going to work with the points for now. We're going to use a technique here, a very interesting one. We can make a voxelized mesh from points, where the points are converted to volume, then the volume is converted to mesh. Because I don't actually think you can do points to mesh yet. You can do mesh to points, but not points to mesh. So we're going to do points to volume, where we're essentially, as you can see, turning those points into a volume object, and then we can turn the volume to mesh. So again, we have recreated a big chungus. So distributing a semi-random number of points around the mesh, depending on our density value here, and we're using this to create a new mesh object, but it's very thick. So we're gonna need to change some of these values. I'm gonna up the distribute point value to 2000 because we need a good coverage to do this properly. We're gonna keep the resolution on amount. We're gonna change the voxel amount to 200 to give us more detail. We're going to change the radius down to 0.06. That's going to bring it a bit more down to a realistic size, and we'll leave those values the same. So we're creating a new layer of voxelized mesh around our result. But what if we don't want this new layer covering the entire surface of the object? What we're going to do is make another Voronoi texture and a ramp, and plug the color in here, and then plug this into the selection of the distribute points on face. If I move this ramp now, what you can see is that we're taking chunks away from it. So if I use a join geometry again to plug our new mesh result and combine these to the output, you can now see that as I move this color ramp, we are now kind of procedurally building up an extra layer of mesh around our first result. So again, taking another artistic demonstration break, here's a kind of snow effect, if you like. Now this is taking a while to record. I need to take a quick break and take the dog for a walk. We'll be back in a second. Okay, I'm back. So we now know how to control where this new voxelized mesh is going to be placed around the character, but this is not the only way that we can remove geometry. So I want to make a quick note about the delete geometry node. If you look at this one, you'll notice that it's got a selection input as well. So if I plug this in between our voxelized mesh and the join geometry, first of all, if nothing is provided to the selection, then everything is deleted. But if we plug in our color ramp to this as well, we can see that not only is it restricting where the voxels are being placed, it's also randomly choosing where to remove geometry. I say randomly, it's not really random, it's just because the Voronoi is randomly generated. So you can see here that it's removing it from the islands. And if I change the color ramp, then it's going to do that as well. But it's a bit difficult to see because we're using the same ramp for both things. But one point I just want to make about this is that because the delete geometry is just deleting geometry and we're doing it after the fact, it's a bit untidy because it's just removing faces from the islands, and it doesn't really make sense here. But I'm going to show you something interesting. First of all, we're going to unplug this delete geometry for now, because we've got something interesting in store for this. Now that we have a voxelized mesh layer going around the character, let's try and displace it. Now we've already done this with our first geometry nodes tree. So what we're going to do is copy some of these nodes. We're going to take whatever mapping you're using, the image texture, the ramp, the normal and the multiply, and the scale with the set position. So this is all the displacement stuff. Let's take this, copy, and I'm gonna, I would paste it in there, but this clipboard's empty. Copy and pasting in Blender is always a bit weird. There we go. Okay, so these are our displacement nodes. We're gonna take the volume to mesh to the set position. We're gonna make sure that this is the one that's passed to the joint geometry. Okay. So we can already see that because we've just copied over these nodes that we were using from the first tree, it's trying to displace the same cross texture on our new voxelized mesh. Now again, this is a key point about the geometry node's benefit over the regular modifier stack, is that we now have displacement happening on two different parts of the mesh. One is generated, one's just the original mesh, and we can have them be different values and different textures and whatever, but it's all acting within the same modifier stack. So say I could change this image to the circle one, and there's not enough really geometry here to see what's going on, you can just see it slightly. But we have the cross displacement acting on the original mesh, and the circle displacement acting on the generated layer. So I'm going to do a similar thing to what I did before, and make an image input from this image texture. So now again, we can change the displacement for this extra layer on the fly. Now to make this a bit easier to see, we're going to change some values. I'm going to change the voxel amount to 500 to give us some more detail. Again, you might want to choose different values for this depending on what your computer is capable of. I'm going to set the triplanar scale to 2, so we have some wider circles going on. Voxel radius, I think, could go a bit lower to 0.03, so we're taking up less inflated space away from the mesh. And the displacement multiplier, I'm going to set to 0.05, so it's a bit stronger. But then I also want to widen this color ramp a bit, so the values aren't as harsh. And I think that'll be a good balance for the displacement on the voxel layer. And if you remember back to the original result that we took a look at the beginning, you can start to see how this is coming together. But now the question is, how do we set materials? Because obviously an object can only really have a set number of materials, and they're usually assigned to the different faces or vertices or whatever. With geometry nodes, when we're generating new geometry, how do we tell Blender what material this should be? Now yes, as you can imagine, there is a node for that. And what do you think it's called? Of course, it's set material. So we can plug that in here. And then I'm going to make it one of my PBR materials, PBR001. And here you can see, unfortunately, it's the same one that I have for the lower. So actually, maybe I'll change this to like 022, make it a bit of a darker orange. And you can see here how we have our original kind of golden cross displacement. And then over the top of it, we have our voxelized mesh layer with these displaced circles around them. Now, these materials are AO-based materials, which is why they're darker around where geometry is intersecting. Maybe not even intersecting, just coming close to each other. If you want to take a quick look at this material, here it is. So the top ambient occlusion is restricted by a color ramp, and that's where the orange comes in. And then for the roughness, we're using a Musgrave texture powered by the object texture coordinate. And with these values, it gives us a nice high frequency randomized surface difference. And you can see that here where we have the Musgrave texture creating the roughness on our original character. Okay, so that's fine. But now I'm going to show you a little trick for how to slice off areas of a mesh. So I've still got my delete geometry node hanging around here. What I'm going to do is I'm going to put this in between the set position, so we know that our displacement is done, and the set material. So we're going to do our slicing in between here. There we go. Now, when I say slicing, what I mean is we're going to be able to get a cross section of the mesh. So to do this, I'm going to make a position node again and a separate XYZ node or XYZ. I'm going to make a math node because what we're going to do is we're going to perform some operations on each of the different coordinates. So X, Y, and Z, plug these in appropriately. And I'm going to set them at 0 for now, but we'll change these. Then I want to mix RGB node. I'm going to make 2 of them. But before we do that, let me plug in just the X value. And let me show you what's happening here. So as you can see, when I give just the X position value here, it's drawing a line straight down the middle of the world. And by adding extra data to this, so adding and subtracting a value, we can create a cross section along this X plane. Same thing again, if I plug in the Y value and I move this in reverse this time, then we can see the effect start to grow up the legs. So it might be easier to see that in the rendered view. So more and more of it takes over the mesh until we have the entire thing. So this is how you can create cross sections, but if you want to mix them all together, I'm sure there's a way you can do it using the math nodes. However, because I'm a bit maths dyslexic, my solution was just to mix them all together with the mix RGB nodes and then try different modes until one of them eventually worked. So color dodge, factors all the way up, plug that in, and now technically speaking, we have control over it. So if I do -3 for the X, -2 for the Y, so you can see it coming back now, and we'll leave Z at 0 because we don't really need that. So if I play with these values, let's actually bring the X back closer towards 0, and we can see the cross section for the X going on, where we're now revealing the arm. And then if I bring the Y down, it's now also considering the cross section for the Y, so we can essentially cut off different sections of the mesh using these axes. And now I think that's good for what we're essentially doing is just cropping it down to a certain part of the mesh. So if I wanted, I could exclude the head from having this effect by modifying the values and just bringing it all the way up to the neck, like that. So now the darker orange section is only happening on the rest of the body. Now this is not an ideal way to exclude different parts of a mesh, and I'm going to show you the much better way, which is the weight painting, but I just thought this would be an interesting little tip to keep in mind. So I'm actually going to just bypass this delete geometry node again because we're not going to need it. If you ever want to use that method, you can, but for now, let's do what I said we were going to do. I'm going to disable our second geometry node tree because we're going to use the weight method for both of these, but we'll focus on the first one first. This is a messy tree though, so let's clean this up a bit. Let's move the group output down. Object info for the set position. We don't need you anymore. Let's get rid of our original generated textures. Okay, so we can work with this. The thing we want to focus on here is where we're doing our displacement, which is caused by the set position node in this first tree. You can see this selection value, and this is going to basically dictate where on the mesh we're going to be displacing. So if we wanted to exclude the head, the hands, the feet from the effect, then we need to plug something into the selection. If you watch one of my previous geometry nodes videos, you already know how this works, but what I'm going to do is bring over a copy of the group input again and make an input of the selection value. So here it is over on the right in the modifier stack. At the moment, it's a number, so it's basically just going to be a value between 0 and 1, where 0 means nothing is selected and 1 means everything is selected, but we don't want that because we're not interested in just having Boolean values for everything. We want to provide it with a vertex group. To do that, we press this one button here, which is the attribute toggle, and then it gives us a box where we can type in the name of the group. Now you would be forgiven for thinking that we need to make the group on this object, but this is just our generation result. Because we're using this base mesh on the left as our input, we need to make the group on this object instead. So what I'm going to do is make a new group, and we're going to keep it called group, and then I'll go into the weight paint mode, and here we go. So let's set this up now before we implement it properly. I'm going to just paint using the draw mode all around the head. One thing I should also say here is that I've seen some people in previous videos confused about how to remove the weight influence from a vertex group. You don't use the draw. If you go to subtract, make sure it's on the 1.0 strength value, then it basically just does the opposite thing. Then we can go back to draw and put it back. Now I might fast forward through this process so you don't have to watch me, do all of this manually. Okay, so here we go. We've painted the head, the hands, and the feet. Now one thing to keep in mind here is that because we've added weight to these areas, technically they represent a 1 where the red is. And since we've got this plugged into the geometry nodes tree, 1 would say this is where we want the effect to be, which is not what we want. I mean, technically what I should have done is paint all the areas that aren't the head or the hands or the feet, but that would actually just take too long for me. So instead it'll just be quicker to invert those values in the geonodes tree. So clicking back over to our object here, at the selection input, I'm going to type in group, like that. And you can see immediately that the effect of the displacement is now only happening on the head, the hands, and the feet. Again, it's the opposite of what we want, but we know that this selection is now working. If I wanted, if I click back on our base object here and go back into weight paint, as I paint, you can see the displacement effect now appearing on the character. So you have real-time control over seeing where you want this to happen. And I think that's pretty cool. It's quite fun just to play with. Let me write my name. Okay, I won't do that. Sometimes you might find it difficult to paint while the geometry nodes is going on because it might not be good from a performance perspective, but I've got the inbuilt add-on enabled here that comes with Blender called Modifier Tools, and with this you can toggle the viewport visibility, so that might be a good way to disable your stack if you're going to be doing painting like that. But for now, Let me get this back on. But how do I invert this? Well, one quite easy way to do it is to make a math node, and we're going to do less than. And what we're essentially saying is, if I set it to 1, anything less than 1, so the red value, is where we want the effect to be. So that's exactly what's happening here. We now have this cross-section displacement happening on all of the body area that's less than the red value. So anywhere that's not the head, the hands, and the feet is now being displaced. So does that make sense? I hope you said yes, or you were thinking yes, because now we know how to restrict this procedural effect to a certain part of the mesh. And again, you could also just plug in any kind of random generated noise or any mathematical values you can create procedurally in GeoNodes to the selection. It doesn't have to be a vertex group. It could be anything you like. So let's go back to our second geometry node tree, and we're going to re-enable this one. Again, this is applying to the entire object, so we want to apply the same principle to restrict where this effect is being generated. To do this, our main control for this voxelized mesh is the discrete points on faces, because this node is dictating where we want the voxels to generate around the mesh. So again, I'm going to take one of those group input nodes, create a new selection input, just as we did before, and notice that I'm unplugging the Voronoi and color ramp while I'm doing this. We're going to turn it into a string attribute again and type in group. Now, same thing's happening again. The effect is now only applying to the head and hands. So what do? Well, we make the math node. We set it to less than and make the value 1. So now it's only applying to the areas that are not the head and hands. However, we have now lost the randomization from the Voronoi texture. So again, if I plug that back in, you can see how it's not applying to all of the mesh. We got these procedural like chipped away areas, but if I'm using the input, all of that detail disappears. And that's not what we want. So we're going to, again, use a mix RGB node. We're going to plug in the Voronoi one first, and then we're going to plug in the less than value second. But what mode do we use? This is again one of those moments which I like about geometry nodes because it's so abstract and it's so similar to the shader nodes. I know technically that these two things can mix together in some way, but I don't exactly know how it works or what mode to use. So again, when I was preparing this, it's just a matter of clicking through the different ones and seeing which one is going to keep the restricted values of the Voronoi there, while also subtracting any of the areas that are more than 1. And the actual mode that we need to use here is color burn. So if I turn that all the way up and then plug that into the selection, you can see how we now have the hands, the head, and the feet all clean of effect, and we still maintain the Voronoi chipped away areas as extra details. Now I'm sure again there are other modes you could probably use to do this and uses of the math node, but again from my testing these are the modes that are useful to use for these situations. Now I'm actually going to change the original effect again, because for our final result, this is actually inverted. So let me do minus 0.02 like that. And now also, let me change the scale of this voxel one a bit. Maybe I'll make it a bit smaller. Again, because it's technically parametric, you can play around with these values however you like to get the exact effect that you're looking for. So you can see as I'm changing the scale of the Voronoi, we are changing where the points are going to be placed around the mesh that's going to give us the voxelized overlay. And once again, because we've exposed values on the modifier stack, I can change the textures used for this displacement on the fly. So now I can use the cross for this overlayer, change it back to the circle, do whatever we want. We can also add more geometry by using the Subdivision Surface node, preferably after the fact, if you wanted to make it more detailed. But again, that depends on the power of your computer, whether you have enough processing capability or RAM to keep all of that information in memory. But hopefully this has given you a good introduction of how to combine different layers of effects in a single stack by making use of multiple trees and having them reference the same base mesh elsewhere. Now I have written in support for these types of stacks into the bygen add-on, and I'm currently working on the first paid pack for this. So this effect we've made today in the pack is called Dorado, which means golden in Spanish, of course. So I'm going to have fun with making some more styles, and then I'll see when this is ready to be released. Because bygen now supports these complex stacks, it means that anyone can technically add these to their content packs if they make any, but there are a few things to keep in mind. So for example, any stacks that have more than one geometry nodes tree need to have in brackets a capital G before their name, because bygen will treat them differently to regular stacks, because it will automatically look through the trees, find any object info nodes and automatically assign it to the base object that was selected. So it doesn't matter how many node trees there are in the stack, it will automatically look through and reassign those for you. But I'll probably provide more information about how to use that properly over time. But what it does mean is that I can do things now where if I make myself a cube again, give it something like, I don't know, not too much geometry, we'll just give it a test, apply this, have it selected, and then apply the Dorado effect. it's now going to do the same thing. It's a bit hard to see in this section of the lighting, but it's the same effect being applied. But because there wasn't much geometry underneath, then there's not much to displace with. But basically, if I applied this to my character over here, then it would look the same. So I'm still experimenting with that side of things, and it's proving to be quite fun. But this video has been quite long. I think I'm probably going to end up calling it a crash course, because that's what I usually call the long videos. But hopefully you found this interesting. If you did, then remember to subscribe, because I've got lots of new interesting content coming. Follow me on Twitter or Instagram if you're interested in seeing new updates. I'm having quite a lot of fun putting experiments on there. Sign up to the Patreon if you want to support my projects, because that really helps. Check out the products on Gumroad or Blender Market. Feel free to donate if you find any of that useful. If you made it all the way through this video, then maybe this time leave a, what should we do? A robot emoji? You know, like the robot head? Let's do that one. So if you made it all the way through, leave a robot emoji in the comments and let me know what you thought. Remember to like and share the video. So thanks for watching, everyone. Hopefully this was useful. Stay safe. Happy New Year as well, of course. And I will see you next time.